Welcome back, folks. So in this video, we're going to talk about how we can use algebra tiles to multiply polynomials. And there should be a link to a previous video, either, well, not from me, that I found, about what a polynomial actually is. And then in the video after this, we're going to kind of generalize, that's the word I'm looking for. We're going to generalize this process and just use this thing called a generic rectangle, because you're not always going to have algebra tiles on you, but we're going to basically take the algebra tile idea or the visual and kind of simplify it so it's easier to draw and to do on the fly. So let's work this example. And so the idea here is we could take any product and turn it into a sum. This will always work. Remember in one of the other videos I mentioned that you can't always turn a sum into a product, but product to sum is always possible. So let's do this. Let's pretend I want to multiply. We want to multiply. I'll say x plus 3 by y plus 7. Pretend. Okay, so if we think back to what we were doing with the rectangle, that would mean that one side length would be x plus 3 and one side would be y plus 7. So what I'm going to do is I'm going to bust out my algebra tiles and kind of show you how I would tackle this problem. All right, so what I've done here is I've created a sort of frame. So you can see here, our problem was we want to we want to create a rectangle where it's one side length is x plus 3, so that's how tall this one is, x plus 1 plus 1 plus 1, by y plus 7, so that's y, and then 1, 2, 3, 4, 5, 6, 7 1 pieces. Okay, what's nice now is that we just need to fill in this rectangle and it will have the correct area because it has the same, as long as it doesn't exceed and as long as it fills out this entire thing, it will have the correct area. Okay, so here's how we can do this. Check this out. If I break it up into a bunch of little rectangles, check out inside here. This rectangle will have dimensions of x by y, and thus an area of x times y. Hold on, we actually have the exact right tile to do that, and it's going to be xy. The xy tile fits in there perfectly, super snug. Okay, so let's look up here now. Well, I need to fill out this, so if I break it up into this rectangle, just this 1 by y, the tile that's 1 by y has area y. So I'll use this one, and that fits in there, nice and perfect. So I'm going to need 2 more of those to fill this out. Pretty neat. Okay, similarly, we know that these ones down here, or this one right here, this little sliver is going to be x tall by 1 wide, and so we can pull out an x. And I'm going to need a bunch of these. I'm actually going to need 7 of them, right? 3, 4, 5, 6, and 7 here. The last part here is I need to fill in this chunk of the rectangle. Well, you might be able to see how much I'm going to need, but I'll just count this one. Let's see. We know that the x and the y tile, these short sides are both 1 unit long. My forehead's so too shiny, I must be sweating. Sorry about that. Since they're 1 by 1 in this little corner right here, I'm going to have to just fill it in with the little 1 tile. And you can see how many I'm going to need. Well, to fill this up, I'm just going to need 3 of them that way, and to fill them, how many more of these sets of 3 am I going to need? I think I'm going to need 7 total. And so what is cool about this is that you can copy paste on this website, by the way. So there's one right there. That's the third one. 4, 5, 6, and 7. Okay, so this rectangle, again, take away the kind of supports here of your frame. Take these away. This area, or sorry, this rectangle indeed has an area, I think we can agree now, has an area of x plus 3 length times y plus 7 width. Question is now, how do I write this area as a sum now? So let's take a look at that in OneNote. Okay, so we're back in OneNote. I've copy pasted that rectangle And I've just drawn up the dimensions once again. So again, the product, the area, this is the area represented as a product, multiplying the length and the width, or base times height, however you want to say it. Now, if I want the area as a sum, again, sum, that just means adding up all the individual areas that we can find. What's nice about the algebra tiles is that it's broken up by color. So let's add them up by, again, in alphabetical order is usually the way you're going to want to do it. So I'll start off with just the x. Well, how many x's do I have? I have 1, 2, 3, 4, 5, 6, 7 of them. So I'm going to have 7x. Again, what I'm doing here is just adding up all the individual areas of the tiles. Let's see, the next one will be the xy tile, and there's only one of them. So we'll add in xy, like so. Let's see, the y's now, well, there's 3 y's, y plus y plus y. So that'll be 3y. And let's see, how many 1 tiles are there? So no x's, no y's, just how many unit tiles? Let's see, it looks like I have 3 rows of 7. So I could count them up. Or 3 rows of 7. I think I'd figured that out by 3 times 7, which is 21. And so this is the area. Now, there are no more like terms, right? All their variables are different in each of the pieces, so I can't combine them any more than they are now. Okay? But that is how you can use the algebra tiles to turn a product into a sum. Again, both of these numbers represent the same thing. They both represent the area of this rectangle. They're just two different ways of looking at it. And so now, whenever I say, hey, here's a product, multiply it, you should be able to get it into a sum. Now, again, if you don't have the algebra tiles, how could you do it? Well, what we're going to do in the next video is we're going to take this same idea and kind of redraw this rectangle, but without using all the algebra tiles. And I'll show you what I mean in that next video. All right, so I'll see you there.